Let's try some more linear relations problems. You make $50 for showing up to your job site and you charge $40 per hour. So we say y equals the slope, which means rate of change is $40 per hour. So the number in front of the x is $40 per hour. X represents the number of hours. But you also make $50 just for showing up, so you get a free extra $50. Even when X, which is the amount of hours you work, is 0, you still get paid $50. So let's sketch this graph. We start off with the y-intercept is 50, because when x equals 0, 0 times 40 is 0, plus 50 is here. And this graph is quite steep, because you're making a very good hourly wage. And the bigger this slope is, the bigger this rate of change 40 is, the steeper the graph. So how much do you make for working 8 hours? So we have the equation here, and we say y equals 40 times time, or x, which is 8, plus 50. 8 times 4 is 32, so we have 320, plus 50 is $370. By the way, relating to this graph, when x or time equals 1, you can see what happens. We get a new point here, and 40 times 1 is 40, plus 40 plus 50 is 90. So we'll make this a 90 here. And now the question is, how long do you have to work to earn $290? So the goal is 290, and we have the equation y equals 40x plus 50. Y is the amount of money that you have. So we have 40x, we could also use t for time, plus 50. This is just basic algebra involving equations. Let's subtract both sides by 50. 290 minus 50 is 240 equals 40x. We can divide both sides by 10, so these zeros get knocked off. And so we have 24 equals 4x. Divide both sides by 4, we have x equals 6. So 6 hours later, we'll reach our goal of $290. Let's try another word problem involving lines. You go canoeing and have an initial energy level of 72. Each kilometer you travel, you lose 3 units of energy. So losing energy is like losing y values. This is like a slope of -3. Gaining is +3. Subtracting is -3. So if we thought this as our traditional y equals mx plus b graph, we'd have y as your energy level equals not +3 but -3x, where x is time, plus some initial energy level, which is given as 72. Now here we're not using y's and x's, we're using e and distance d. And so the energy level y, or e, depends on how far you travel, x or d. So we'll just replace x with d. So we successfully modeled this energy distance formula, and we can now substitute. The distance is 10 kilometers. So the energy equals -3 times 10 plus 72. In other words, we have -30 plus 72, which is 42 units of energy. Now this energy formula can also be written as energy is a function of time equals -3d plus 72. This doesn't mean E times T, it just means energy depends on time. Specifically, when we run out of energy is when the whole E of T, or E, equals 0. So the question is, can we figure out this distance in which we have no energy? We throw the -3d over, we have +3d equals 72, and we divide both sides by 3. Using long division, we have 72 divided by 3. 3 times 2 is 6. And then we drop the 2 down, and 3 times 4 is 12, and have no remainder. So we have d equals 24. This here is the distance of time in order for us to run out of energy.